Hello everyone, this is the first lesson recording. Hello everyone, this is the first lesson recording for IM2, September 14th, 2020. Few announcements. You will have the unit test next class, so please prepare accordingly. The topics will include quiz 1 topics like solving linear equation, going from graphs to equations to point, geometry vocabulary, solve for angles using linear, vertical angle, and triangle sum, but there will be no parallel line angles, and I will look into whether today's material will be on the test or not. There is extra office hours during Wednesday morning and afternoon during the outreach. I should be done with the outreach in about 10 minutes so that I can join you like 10:20 or in the afternoon from 2:10. Last day to submit late homework is the end of day on Thursday. Ideally, it should be done before Wednesday night, because so that you will, whatever the work that you do, that it will be somewhat helpful for the test. So homework today is the review packet, and it's available on Canvas right now, and the answer key with worked out solution will be available for you tomorrow night. What are we doing today? We are going to be talking about triangle side inequality and properties of isosceles triangles. So to explore that, we're going to go into Desmos activity, and we're going to be asking this question: can a triangle be formed by 3 segments of any given length? You know that triangle is formed by 3 different sides, like for example 9, 14, and 17. Is there limitations? Is there restrictions to these numbers, or can it be any all numbers and it's fine? We're going to be exploring that. So you are going to log into your Desmos class login if you have not done so already. Go to student.desmos.com and use the join code for the class. Here you go. So this is the Desmos activity. I'm just going to quickly go through with you. You were supposed to have done this on your own, and that way, as I go through with you, that it will make some sense. Can a triangle be formed by 3 segments of any given length? This is opinion question. Do you think you can? Is there any restriction, or is there some restriction? Yes or no? Okay, then let's try this. Can a triangle be formed with these 3 side lengths? Try moving the 2 points labeled B. There is my B and there's my B until they coincide. Remember, we need to form an enclosed shape in order for it to be a triangle. Can I move this? And can this point B and point B ever coincide? No. So with this length of 3 units, 4 units, and 25 units, you cannot form a triangle. So I'm going to say no. And you were supposed to come up with an explanation, but I'm not going to do that since I'm talking that out loud. Okay, what about this? It used to look like this, and you were supposed to move. Okay, so can I move this? Let's see, I can move it over here and maybe move it over here. That's pretty good. They are coinciding. So yes, I have formed a triangle, so I can say yes. Okay. What about next one? You should have had sides that look like this. Can the triangles be formed with these lengths? Well, if I move it over here, okay, that's going too far. Okay, so then let's try to move the other side to match it. Oh, no, it's never going to match, is it? It's never going to coincide. So I'm going to say no. Okay, so I can say something like AB is too long. All right, then let's try the next one. Can a triangle be formed with this side length? Okay, 9, 4, and 12 this time. 9, 4, and 12. Good. Okay, so I can say yes. What about this? Okay, so that's going too long. Okay, so let's see if I can move it. Okay, that's pretty close. Okay, so they are coinciding and I was able to form a triangle. So I am going to say yes. Alright, what about this? You had lines that look like this. So we have 15, 6, and 9. So in order for it to be a triangle, I need to bring it over here. It's close, but it's not quite coinciding, is it? Will it ever be able to coincide? I don't think so. So I'm going to say no. Okay? So summarize what you learned from the previous example. You should be your answer should be a response to one or both of the questions below. What do you notice about the relationship between side length when you could form a triangle? What do you notice about relationship between the side length when you could not form a triangle? So basically, you could sometimes form a triangle, sometimes not. It really depends on the length, right? So let's go to the next one. Okay, so this time you're given this triangle that looks like this. Okay, so segment MP is 10 units long. Okay, MP is 10 units long and NP is 7 units. We can move this point N to figure out what is the maximum and what is the minimal length that this could be in order to still form a triangle. Okay, so it's from here, if I extend it this way, the length is getting longer and longer and longer and longer, right? Okay, what is the biggest number it could possibly be? What's the maximum number? I see 16.94 here. Okay, can I make it any longer? Oh, when I do that, it becomes 17 units. Okay, at 17 units, it just becomes a flat two lines overlapping one another. So it's no longer a triangle. So that's no good. So 17 is no good. 18 for sure is definitely no good. But we can say that 16.94 was good. Okay, let me go back to that. Or 16.88 would work. Okay, is that the biggest number that it can go? Well, in theory, it can go to 16.99999 as long as it's just a little bit smaller than 17. What about, let's explore the minimum. If I go the other direction, the side length is going to get smaller and smaller and smaller. Okay, what is the smallest it can be? Okay, smallest it can be is 3.32 is what I have. Oh, and then it goes to 3 units. Okay, but that is just the Desmos limitation. What is the smallest this length can be? It's actually as long as it's bigger than 3, like 3.0001 would still work. So if it's anything bigger than 3, then it would work. So it needs the length needs to be less than 17 but greater than 3. Okay, so less than 17 but greater than 3. Now, how did the numbers come about? Well, you can go to the next slide and say, in order to create a triangle of the previous graph, a group of geometry students decide the length of the third side has to be longer than 3 units and to be shorter than 17 units, which is what we discovered. Okay, okay, so how did the 7 and 10 units relate to number 17 and 3? How did that come about? Well, 17 comes from 7 plus 10, and you saw it visually, and 3 came from 10 minus 7, or the difference between the two side lengths. So the maximum could be the sum of these two side lengths, and the minimum was the difference of these two side lengths. Okay, so here is the notes that you should be taking. This is the conclusion you should have made. The when you are given two side lengths, say this could be the 7 units and this could be the 10, we said the maximum could be 7 plus 10 or 17, so it has to be less than 17 but bigger than the difference between the B and A. What is the difference? 10 and 7 was 3, but it had to be bigger than 3. So it had to be shorter than the sum of the two sides but longer than the difference of the two sides. Or algebraically you could represent that as the C has to be smaller than 10 plus 7, A plus B, but less than is less than the sum but bigger than the difference. So 10 minus 7 was 3, and there's an absolute value there because whether you do 7 minus 10 or 10 minus 7, it does not matter because the absolute value will take care of that and give you the positive number. Okay, and this is the triangle side inequality theorem, actual theorem. I do want you to write this down, but rather than relying on this, I actually prefer to do this visually. Okay, so if you're given this two side length of 10 and 8, what are the possible length for the third side? Let's do this visually. Oops, let me get rid of that. Okay, so alright, so if you are given side length of 10 and 8, so I can say I have, this could be my 10 units, and I am going to try for the maximum here, maximum, and this is going to be the minimum. Okay, so remember we said that was 10, and we are trying to create two triangles. One is going to be the with maximum length, and one is going to be the minimum length. To create the maximum length, given that this is going to be 8 units, I need it to go go that direction, right? So I'm going to say this is 8. Okay, and to make a triangle with a minimum third side, I need to make this go this direction, and I can say this is 8. Okay, and then finally the third side is going to be joining this. Okay, so you can kind of tell if this is 10 and this is 8, what is this length gonna be? It's going to be at most 10 plus 8, which is 18. But if it's 18, that's no good because that's just going to be a flat two lines. So that's not going to be a triangle. So it has to be, the maximum has to be, the length has to be less than 18. What about in this case? You can see that I can draw this line and you can see what is this length going to be. 10 minus 8 is going to be 2 at 2, and if it was 2, that it would be just on top of each other, right? But this has to be bigger than 2. The x has to be bigger than 2. Okay, so if x is the length, so the length has to be somewhere between at most 18, not including 18, but at least 2. So it has to be bigger than 2 but less than 18. That's the length. Okay, so let's try this one. Okay, see if you can come up with your answer. Okay, so here's my diagram. So if I have 8 units here and I have one of the side being 5 and the other side being 2, can I form a triangle? No, because if at the most, will those 2 points ever meet? They will not. So I cannot form a triangle. Okay? Okay, so this time it's your turn. Please pause the video and see if you can form a triangle like from here. And I am going to show you the answers in 3, 2, 1. Okay, those two are the only ones that you can form a triangle. the number 4, it's going to be a flat line, so that's not going to be possible. Okay, I'm going to continue with the next video.